All right. Okay. We'll go like this. All right. Maybe I can. I don't want that thing to fall down again. I'll hold it. Okay. There. Is that better? It's better for me. Okay. And I don't have a piece of paper. Can somebody give me a piece of paper so we can do the sign-in sheet? Or maybe you can. Do you have a piece of paper or you don't have a piece of paper? Student without a piece of paper. Is it all just about the computer? So, yeah. Thank you. Wow. Can't believe education has totally changed and transformed. And I didn't even plug in my headset. Forgot. Hold on. Here it is. Let's make sure that our sound is working. So I'm frazzled. Okay, let's check and make sure that we've got our sound happening here. Yes, it looks like we do. Okay, so I wonder if that's okay. All right, fine. Now, we want you guys to be able to read it, right? There you go. Okay. Is this good for visual? Can you read this good? Well? You can read it well? Okay, good. Let's see. Tuesday, March 19th. Okay. How's the noise for you? All right. All right, so we're going to talk about food and science today. First, any questions on the exam? Any problems? No issues? I assume I didn't get any messages, so I assume everything's fine. Okay. All right. So for our schedule, we'll do food and science this week. If you remember, next week we're going to be getting into human rights and land, right? And we'll start off with talking about governance, sovereignty, and autonomy, some pretty heavy topics. And then we'll get into international law and human rights. After that, we get in, wow, look at that. Did you see that? It went like that? No? Maybe. Okay.
Yeah.
I don't know why that does that. Okay, and then the next one, we get into peace and conflict negotiation, right? And then cultural survival, lastly. Okay? All right. So, talking about food science today. How many people have seen films or anything like that about the way we produce our food nowadays? Yes.
I saw Food Inc.
Food Inc. Oh,
Yeah.
Yes. Wow. How many people saw that one? Okay, a lot. How many people did not? See, this is how I have to figure it because there's so many. And your thoughts on the film?
It shook me.
Shook you up? Yeah. When did you see it?
I saw it my freshman year of high school, and I was just like,
Oh, wow. So that's a while ago. Yes. Okay.
it still impacted me. I was like, I'm never gonna eat meat again.
Never gonna eat meat again.
But then the next day,
The next day you ate meat. Are you still eating meat, or are you?
yeah, it's just
Yeah. It's a pretty horrible scene, right? I mean, I remember the discussion about the animals, especially the cows, unable to consume what they're being fed, right, for their food, right? So I think that's what you're referring to in terms of meat. Chicken too, right? Didn't they have something on chicken? And they discussed, from my recollection, about how this is a big part of the educational food system, right? Okay. Anything else from that film that you remember?
On animal rights, there's a lot about the farmers themselves.
The farmers, like what?
Monopoly, like
Monopolies, yes.
Monsanto.
Monsanto, yes.
So like just the control they have and how farmers are stuck.
Yes, yes. They get stuck, right? We can talk more about that in a little bit. Anything else that you saw from that film specifically? Okay. Did anybody see, and this wasn't part of the assignments, right? I mean, I was encouraging you to see some of these films, but it's not specific to today. right? Did anybody else see any of these kinds of films or films about food recently? The last couple of years? Yes.
Last year I saw King Corn in.
King Corn. I haven't seen that one.
I think it's something like that. It's about the corn industry.
Yeah.
They talk about Monsanto, and I saw it in Dan's food and sustainability class.
Okay, okay.
They talked about food production and like how farmers are kind of like stuck in like the sense that like it was like these two people kind of like they bought a plot of land and raised corn, and like these farmers kind of like guided them through the process of like making corn, and when they realized that like the corn they're growing is being like sprayed on with like pesticides, but
Right.
you can't eat that corn. It has to get processed at a processing plant, and like it kind of goes through the entire thing. And like at the end of it, it's like you're not even making like enough. Like you have to really buy lots of land to like somehow sustain yourself. And
Right. Okay. Interesting. Very interesting. Did they talk about Mexico and also the Midwest or all around the world?
They talked about some place, I think maybe Mexico, about how they're using like ox to like on their farming land so it's kind of like helping the land. It's not just
Deep
grazing.
tilling instead
Yeah,
of
deep
machine tilling.
yeah.
Okay. Got it. Anybody else with anything, any other film that you've seen? No? Okay. Anybody read any from Michael Pollan? Michael Pollan? You recognize Michael Pollan? Yes, thank you for the you remember I'm dyslexic, so my pronunciation will go all over the place for these things, right? In fact, I think you should say sword when you're saying sword, right? Because it has a W in it, right? Okay. Seriously. Okay. All right. So I would recommend any one of these films. The Future of Food is a really interesting one. It's a little dated in that it's maybe 8 to 10 years old, but the issues are very much the same, and they talk about the science to a fairly good degree. Hidden things in kids' food scared the crap out of me. So look out, right? So it's talking a lot about not just the pesticides in plants specifically, but it's also talking about meats. Do we remember the era of pink slime? Do you know what I'm talking about? You do. What do you remember?
Something in a lot of food.
Something in a lot of food. Yeah, and it stretched it, didn't it? It made it so that they could make more. And does anybody remember what it was? Do you remember what it was? It was like wood products, like paper products that they're putting to stretch. I think one of the taco fast food companies had been found to be doing this, yes, as well as other fast food companies. So that was kind of an interesting thing to see. Okay. Anything else about Michael Pollan Michael Pollan that you remember from his readings or any of his writings? I'm trying to think of one of his most famous books is let's see, Michael Pollan. Botany of Desire is one. Omnivore's Dilemma is another, right? Botany of Desire, do you remember what he said in that?
It was basically about sweetness of apples. And
Sweetness of apples, okay.
spoke a lot about marijuana as well.
Okay, in terms of things that we're attracted to as human beings and what we like to consume and stuff like that, right? Wine, coffee, sugar, drugs, or legal or illegal, right? All those kinds of things. Now, Omnivore's Dilemma, he's talking about, what's an omnivore? Okay, so he's talking about a dilemma for somebody that is a plant eater and also for somebody that's a meat eater. And what is the dilemma? Do you know? Why would you be concerned as an environmentalist about eating meat? Any thoughts? Yes. Releases a lot of CO2, right? Okay, so the cows, we've actually studied this. They fart too much, and it's like horrible methane gas. And as we raise them more and more, that's one piece. What's the other piece about raising cows? The processing plants is another thing. What about how they're disrupting the environment that maybe was there before? Do we know that the number one threat to rainforests is cattle? Do we know that? Don't know that. Okay. Number one threat to rainforests is cattle. Number one production in Nicaragua of any product is beef. What does that tell you about our rainforest and our rainforest friends? What do you think? It's getting smaller every day. Why? Because we have more and more illegal people, colonists they call them, coming in with cattle and having to graze, and it's forcing them to cut down the forest, and the forest never regrows because they just graze everything that comes up, right? This is the thing about cows. They just wipe out everything. Okay, kind of like goats, yeah? Okay, so in terms of that, it's wiping out a lot of the rainforest. Also, it's a huge methane issue. The production is another issue. Now, how much water does it take to make just one single patty? Do we know about that? Water needed to produce one beef patty. How do you feel about that? Oh, crap, right? So here's your dilemma. If you want to eat, you're making the climate worse. We're cutting down more rainforest. And look at all the water we're wasting. And it's your fault. Right, okay, so that's the dilemma, right? So that's the discussion. I'm not saying this is a bad thing. I eat meat just like many others, okay? So I'm just telling you what is in the argument, okay? So that's a little bit about what some people have said in terms of food science, right? Outside of GMOs, okay? Oh my God, GMO, OMG, GMO. Anybody watch that one? Has anybody seen that film? No? Okay. Fed Up, anybody seen that one? I showed that one to my freshman class. I had a freshman class, seminar class. It was called Food, What Is It Really? And we all watched Fed Up. Does anybody know what it's about? Sugar. Oh, what do you think it's going to say?
It's bad.
Yeah, it's bad. What else is it going to say? How much sugar did you have this morning? Like for reals?
Probably lots.
I put 3 full tablespoons into my first cup of coffee, the same into my second cup of coffee. I had a glass of orange juice. Bless you. That was a bless you, right? Not laughter. I mean, I get both is acceptable, right? Orange juice, right? I'm drinking some hot chocolate. I just had another orange juice, right? I'm guessing that my tuna sandwich I had for breakfast had some sugar in it, although that sounds weird, but I'm thinking it probably does, right? My day's not over. It's just getting started, right? Oh my gosh. Do you eat that much sugar? I don't even have soda. Do you guys, how many people drink soda? Da, 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 da. Are we all nervous to raise your hands? Okay, it's not bad. It's all right. It's all right. I like my root beer every once in a while, right? But a lot of sugar. Has your sugar consumption gone down here at the university? Or has it gone up? Or is it maintained the same? What do you think? The same?
It's gone down for me.
Gone down.
I'd say there's nothing in the tests.
Nothing in tests, and then it's like, oh, it's good. Mom used to show up with lasagna on test times, right? That was great. Okay. So one of the things that we learned was that we were pretty surprised by how much people consume for sugar. And then when we started tracking it, it was surprising how much we were eating. And then after we started tracking it, it was surprising how little we were eating after looking at it. So that was an interesting exercise, right? Okay. Wanted to put up this little clip here called The Advantages of Genetic Engineering. Okay. If you are interested in watching it, feel free to watch it. One of the things that I try and do in the classroom is I try and give you even sides. It's really difficult because sometimes you get passionate about things, right? So, but for this specific lecture, I'm going to really do what I can to show you both sides. Okay. And that means I'm going to put on my genetic engineering hat and say, yay! And then I'm going to take on my GMO-free hat and say, boo, right? Or yeah, as it were, right? Okay? So we'll start this off. I'll tell you about these presentations, and then we'll start this off with me talking about the pro side of genetic engineering. Okay? All right. Okay, so first thing here, we have a two-part presentation by Pioneer. So Pioneer is a biogenetic engineering company. One of their bases is on Kauai. And we had them on the west side of Kauai. They had a research center, a testing center. They were planting all kinds of things that were brand new, testing seeds, testing their engineering. They had volunteers that would come, right? They would send a community relations person to all of our elementary schools to meet with the elementary schools and show them about engineering. They even sponsored the state fair where they would have the popcorn there that was from their corn, genetic engineered corn, right? So they were fairly present in all of the islands, I would say, even though maybe not everybody realized it. Okay, so you can look in their presentation at a couple of discussions. They'll talk in this about some of their experiments. One widely known genetic experiment coming from Hawaii is about papaya. Has anybody heard of that? Okay, so we started genetically engineering papaya probably in the early 90s, okay? And when we first started doing it, we had a lot of exports going to Japan and Asia of papaya. Interestingly enough, I wouldn't have thought that that would have been the case. I would have thought Japan would grow their own, but we were exporting quite a bit. At that point, they held back all exports because they wanted to see what happened in Hawaii. So we went through like a 10-year test period where we had our papaya engineering tested, and it was eventually put back on the market in Japan. Okay, so that's going to talk about that. It's also going to talk about another experiment that they did, has a few in there, but another experiment that they did on bananas. So we do have a virus in the Hawaiian Islands with bananas, which precludes you from bringing in any other kinds of fruit crops. So you can't leave with fruit and you can't come in with fruit. That's just the way it is in Hawaii. How many people know that? Right, okay. And so one of the things that they did was to experiment with bananas to try and get rid of what is called the bungee top virus. Okay, and in their experiments, they also did some to incorporate vaccines into bananas. Pretty fascinating. Okay, so they talk a little bit about that in those first and second presentations there. So that's a pro side. I encourage you to go check it out. The next presentation, and these are like PowerPoints, okay? So you can just click on them and they should run because they're on my Google Drive, okay? The next presentation is done by Dr. Lauren Pang. And just a side note, the Pioneer Community Relations lady, PhD in bioengineering, used to come into my class, take questions from students, all that kind of stuff. Then I would bring in Dr. Lauren Pang. He is the director for public health for the county of Maui, for the island of Maui, right? And he would come in and talk as an MD about his personal knowledge about genetic engineering and his personal feelings about it. That's more the anti side, okay? And interestingly enough, he has some slides on there that we'll talk about when we get to the anti sides, okay? So next is something by, oh, thank you. I'll take care of these in time. I'm new with this computer now. I think I just click, okay, now it's good. Now we have 4 presentations by Jeffrey Smith. He wrote a book that was called Genetic Roulette. Is it worse than Russian roulette, right? What are we doing with genetic engineering? So that's an anti-side, and he'll give you all of the science there for that side, okay? So those are some things that I wanted to provide for you that you can take a look at on your own. All right. I had one of my colleagues on Kauai that was very supportive of genetic engineering. And so he made it a point to eat all the genetically engineered papaya. So he says, I've been eating genetically engineered papaya for over years and I'm fine. So it was his way to demonstrate to others that it was healthy and fine to eat what was available, even though it was genetically altered. So putting on my pro-GE hat, or genetic engineering hat, bioengineering hat, right? I should talk about the fact that in history, we have some examples of, you could call it genetic engineering, but essentially where we're taking a microorganism or an organism, and we're introducing it to another organism, and we're creating something new, and we're eating it, okay? So this is what we're talking about with genetic engineering, is taking two different organisms and combining them and eating it. So over our history, we've done this quite a lot, okay? Going very far back. Let's think about fermentation. Let's think about bread, right? Wine, beer, bread, yogurt. Anybody have any yogurt for breakfast? Nobody had yogurt? Really? Kefir? No? Okay. It's healthy for you, right? Okay. So essentially, we've been doing this kind of genetic engineering where we combine different organisms for millennia. So to say that this is new technology is really inaccurate. So if you hear people talking about genetic engineering as being new, please know that it's kind of used as fear tactics, okay? So when we're talking about this, you might hear, oh, this is a new technology. You might also hear the terms frankenfood. How many people have heard that? Frankenfood, right? Okay. Frankenfish is now what we're talking about with the salmon. I don't know if you've seen some of the news on that, just came out, okay? Talk about it. We'll get there. So, not necessarily what we want to do with science. Remember we talked about Luddites? Remember we talked about Edward Ludd last week? I said, remember when we spoke about Garrett Hardin, he was talking about the tragedy of the commons and everything. We had the textile industry in England, right? And then we had people that protested the textile industry, said, it's bad, right? And they called them Luddites because they were led by Edward Ludd, right? So don't be a Luddite. Don't be an anti-science person just because you want to be anti-science. Let's take a look at this and what's going on with the science and what our history has been and be a little bit more open to it, okay? Now, you also should know that there's something called chymosine that we've been producing since the 80s. So I've been eating GMOs since I was a little tyke, right? Little kid. I'm fine, right? So we have been genetically engineering the enzymes that we use in the production of cheese, especially some of the hard cheeses. Anybody interested in eating cheese with the stomach gut of animals? Me neither. Oh, you do? Yeah, okay, well, it's a different kind of rennet, right? It's got a different kind of taste. I actually used to eat it a lot and loved it, and they make some great Nicaraguan cheeses with just that rennet, right? But if you don't want to, we can look at other kinds of genetically altered enzymes for cheese that aren't an animal product. So you can eat it without having meat in your cheese if you so desire, right? Or if you want to be vegan, right, and make your cheese with soy or whatever have you, maybe one of your almond milks, right? You know, you can do this, curdle it and make it into a cheese and make it with just a non-animal product, okay? So we've been engineering these since the 80s. More than 60% of all of your hard cheeses are made this way. So you too have been eating these even though if you thought you were not, okay? All right. So a little bit of news on cheese, right? Cheese is playing a divisive role in GMO labeling, perhaps because we've been doing it for so long. Genetically modified cheese is nothing safe at the boundaries of GMO controversy. And could farm camel milk coagulant be used to produce horse or zebra cheese? Would you eat zebra cheese? No? What about goat cheese? How many people like goat cheese? I love goat cheese. It's really good, right? I like goat milk too. Had the opportunity to have fresh goat milk over the summer. It was really good. Okay. All right, now let's talk about what it is that we want to accomplish in genetic engineering, okay? Because a lot of those that are criticizing the pro-genetic engineering side are saying, oh, it's all about controlling population, feeding you something sick, it's all about the dollar, right? How many people have heard these things? Heard anything else? Okay. Well, think about this. Remember that in the genetic engineering process, it's a very complex process that goes on in a lab, right? Where we're trying to fuse organisms together somehow, something that's not common in nature. In addition, we're spending a lot of time researching what happens in the next subsequent generations. Is it healthy for you? Is it good to eat? Does it taste good? Does it keep its value, duration, flavor, etc.? So there's a lot that goes into the genetic engineering of food. A lot of effort, a lot of time, and a lot of the people that are doing it have PhDs in bioengineering. So it's a pretty penny as well, right? Which means that we better be doing it for something that's going to catch value. If we're feeding you something that's going to get you sick, that makes you sick, we're not going to get value because it's not going to be sold or it's not going to be bought, right? So there's an interest in making a product that is good and useful, okay? In other words, let's make that genetically engineered banana plant that takes care of the bungee top virus so we don't ever have to deal with it, and we can sell our bananas and they're all healthy and they're all well produced and we don't have to be concerned about illnesses anymore, right? Or pests. Okay, so that in mind, there's a couple of things that we have in terms of our focus, right? We have an interest in the quality of the product, right? So what kinds of things have we been working on? Carbohydrate metabolism. Let's see. Anybody had some of Burger King's Satis fries? Do you remember Satis fries? Does anybody remember this? Oops. Well, you remember that guy. Okay, maybe. Let's get some images so you can see what Satis fries look like. Ah, the ribbed ones. Do you remember those? The ridgy kinds. I used to always avoid those. I always liked the skinny ones. Do you like these kind? Some people like these kind, right? Don't remember. Okay? Burger King sold Satis fries, right? We've trimmed the fat. What? Okay, so what they did was they took a potato that was genetically altered to be able to process the carbohydrates a lot faster, okay? Therefore, we've trimmed the fat. You can eat the same quantity and it won't have the caloric value as anything that was on the market before, okay? Satis fries, right? So we have the ability to change the metabolism of carbohydrates within food products. We can design something that can be metabolized a lot faster. Yay! Color. How many people like yellow strawberries? No, ugh, right? I mean, I've had some yellow watermelon, some orange watermelon, some red. Have you seen those? Wow, stop. They're really good, right? Okay, but like yellow strawberries, I'm not into, right? So, in other words, we have a certain preference for color, yes? And because of that preference, things are sold or things are not sold. So we can adjust this so that the farmer can produce something that, while it might not be desirable to purchase, because it's genetically engineered, it will be. Okay? So it might potentially be something that's part of those ugly foods. You ever hear about ugly foods? You know, like you can buy ugly foods for a discounted price. Did you know that? Yeah, it's like really cool, right? I think let's see, National Geographic Ugly Foods. I think they did a thing on ugly foods, right? Food waste wants you to eat ugly foods, right? So like there's a thing about, hey, everybody eat the ugly foods, right? Well, ugly foods aren't being bought. That means the farmer is suffering, right? Durability. Also, if we're growing products that are so temporal that they might be ruined by the time that they finally get to the market, that doesn't work for anybody. That doesn't work for the farmer. That doesn't work for the buyer. That doesn't work for the consumer either. So we can engineer it so that it can have a longer process of duration. We can even take care of a lot of our food issues, food storage issues for the future, population food issues by just genetically engineering some of this stuff, okay? So this is what we're looking at. Fatty acid metabolism, same as the carbohydrate. Firmness, same idea. This is all about the product quality. Delay the ripening so that by the time it eventually gets to market, it's perfectly ripe, just for you, tastes delicious. And make sure that the processing value is where it needs to be for the farmer, right? So if we have something like taro farmers had, which was, we had leaf blight, and we had something that was called guava seed, which wasn't guava seed, but it looked like it, like little droplets of guava seed in the middle of the corn. It was really weird. You had to cut it out, right? Okay, and the leaf blight made it so the corns didn't grow very big. These guys can change it so that those products will be grown and they'll be resistant to those diseases, right? Like just like the vaccine, we put a little bit in, it's resistant to those diseases, you grow better corn, perfect, right? Pest resistance. Talking about the bungee top virus. Okay, not a pest, but we also have other kinds of pests that are attacking things, from aphids to worms to you name it. How many people have tried farming? A little bit? Yeah, tried farming. Ever been grow something? Yeah, like fruit and something that you ate, anything like that? Yeah, it's hard, huh? I mean, we're trying to grow stuff in the backyard, tomatoes and I was gonna say pickles, no, cucumbers, right? Chili peppers, starting to get real spicy ones now. But it's hard work, and there's a lot of bugs and worms and things that attack it, right? We can now design these kinds of crops so that the worms won't even want to come near it. Yay! Be gone worries of pest control, right? Okay, so bacterial resistance, fungus, insects, nematodes. Anybody know about nematodes? This is one way that you can tell that a papaya needs to be cut down. It's like done with, overall done with. All the papaya leaves turn real teeny tiny. It's like they've been attacked by nematodes. Cut it down, start over, right? I love papayas. So good. Oh, it's still hot in here. It's not getting any better. I'm sorry. Okay. So, pests, product quality, agronomics. Anybody concerned about the supply of water these days? Okay, well, maybe not in our state for the very moment, but like overall general, yes. I mean, it's been so bad for us as a state that, do you know who we entrusted in the last couple of years to manage our state water system?
Wasn't it Nestle?
No, close with the letters, right? NASA. What? NASA. No, not people walking the rivers on the ground and testing the stuff. No, NASA. Why are we using NASA to manage our water system in the state of California? Right? Because there's so little of it. And we've gotten down to the point where every little last drop counts. And now we have to use satellite imagery to try and figure out how much is left, take a look at what we were at and where we're going, and all the shrinking of different reservoirs and the like. Right? So we're worried about drought. Maybe not this year, but probably next year, I'm guessing, right? So now we can engineer these crops so that they have longer root systems. You know this? Longer roots, then go deeper into the water table. Yay! Doesn't matter if we have drought. They'll go deeper to where the water is. Or we can also engineer them to survive on less water. Great, right? Do you remember we talked about trees? We talked about climate change before, and I said, you're not going to believe what we're doing with trees. Do you remember? What do we say about trees? We're now engineering them to take in more carbon. What do you think about that? Forget all these regulations. We can just grow trees that can take in more carbon. Just grow a couple of those that are 100% times the regular rate and fine, right? Science, yes. Don't be a Luddite, right? So, herbicide tolerance, that means if we do have bugs, we can spray for the bugs and it won't kill the plant. Yay! Right? Easier farming. Hybrid system, we can grow different kinds of crops together or even splice kinds of crops and make new things. We do this in animals all the time, right? We made a labradoodle or something like that. You remember these, right? Okay. Nitrogen reduction. This is one of our concerns. We have some concerns about available nutrients in the future. Phosphate, oh my goodness. We think it's coming to an end. This is something that we use for farming. Same thing with nitrogen, right? So if we can grow our crops without the heavy need of these things, maybe that's a better thing. Salt. Why are we worried about salt? Where does salt come from? I mean, like, not the ocean. Don't tell me that. Like, how can we have salt in our fields? Do we have salt in our fields? Why? Because everybody keeps throwing salt in. No. Okay, so you use a lot of fertilizer and it builds up salt. Strange, right? But it's true. Okay, so this is what we call salinization. Okay, and a lot of what we experienced in the Fertile Crescent at one point was suffering from this kind of same issue, too much salt. We also discovered this on the North Shore of the Big Island in Hawaii, found that what was going on in Waipio Valley, wow, intensive growing of things, evidence, salt. Go figure, right? So it was like fertilizer that was being used from natural sources, okay? A lot of people put banana trees into the taro patches to give them nitrogen. It's a source of fertilizer, okay? Others, they use like castor oil leaves to prevent bugs, right? Get them both in there and it produces some kinds of residues, okay? Temperature resistance, oh my goodness. Saw a lot of crazy temperatures this year, didn't we? Like, I thought it was gonna snow way down south, like, ooh, but it did. Did you see the pictures? Malibu, snow. What? Anybody see that? That was the weirdest picture of, the beach in Malibu with snow all over it. I would have never guessed, right? So we might have some temperature changes. Let's engineer it so that it can handle it. No need this problem about frost and citrus, right? Last year, we lost hundreds of millions of dollars to frost that hit the citrus industry. Happens every couple of years, right? Devastates our agricultural crops. All of the prices for those products go up, right? Orange juice, very expensive then, okay? We can counteract that by engineering it so that the genes of the things that we grow are going to be able to deal with it, right? Metal. Maybe we have some source of metal, be it, contamination or something like that. Now we can address that as well. So it won't affect our food, okay? Right, so those are kind of some of the focuses of why we might do genetic engineering, some of the issues that we're looking at addressing in the field, right? And you could also say that we're looking to feed the world, right? Provide more food for the world as well, as provide other kinds of products that are possible for their desirability as well, and dealing with mediating a changing environment, okay? So, a couple of methods. One is fairly new. The one on the bottom, the CRISPR, is fairly new. How many people have heard of the CRISPR? 1, 2, 3, 4, 5. Yeah, okay. Where'd you guys hear about it?
Bio. Yeah.
Biological class? Bio class? Anywhere else? Nowhere else, just bio class? What'd you hear?
Yeah.
Weird thing, huh? It's a weird name, weird thing. What do they do? Do you remember?
Isn't it like edit genes?
Yes, gene editing. How do they do it?
was like splicing.
Yeah.
There's, they go in with this kind of thing that cuts, right? It's like scissors, right? And then they remove genetic pieces and they put in genetic pieces. So that's why it's editing. It's like, put that out and put this in, right? Okay. Kind of new though, right? Just getting started. Not really at the level of our food yet, okay? They've been working on grasses, okay? Is that what you guys talked about? Did you talk about grasses and what they've been producing? Not so much. Okay, so lately what they've been doing with the CRISPR has been to produce grasses that grow slower. Yay! Why do we say yay? So you don't have to mow the lawn, right? And what else? Think environmentally. It doesn't take in as much. Yay! Okay, which is important here because, man, we even have programs where they'll pay for you to take out all your lawn. Did you know that? Yeah, and just put in stones and things that don't take up much water. Okay, so we're into like the low water kind of thing, especially here, right? So starting that off with a bunch of grasses and things that are now, from my understanding, being sold in Walmart. So you can buy some of those grasses now in Walmart. And you might notice some of the lower growing numbers, okay? There's some concern about it as well. Did you talk about concerns in your class? I saw you guys raise your hands, and you knew about the CRISPR too, right? Did they talk about any concerns?
Well, from what I know, there are like some
Ethical.
because we were talking about it from like a human editing standpoint.
Genes of humans. Okay, so one of the things that we did, right? Right? You know that we did already? Okay. Let's see if I can find it. No, that's not going to list it. Genetic engineering. How do you spell embryo? Y. Oh, thank you. This is just debilitating. Embryo, genetic engineering, embryo, 3 parents. Three-parent babies, yeah. So this came out in 2018 when we started really getting into discussing this as an issue. So one of the things that we did with the CRISPR was to take 3 parents. We needed an egg, and then we had 2 males that wanted to be the parents. And we made it so that they're parents. So it's the first time ever that we were able to assert that 2 men can be the parents of 1 child with the use of a 3rd person with the egg. How many people knew about that? Okay, yeah, wow, mind-blowing stuff. It was amazing when the news first came out. And some of our concerns have been related to, is it ethical to engineer people, right? So there's a discussion that we could just tweak other kinds of genes as well. It's fairly easy to edit. In fact, it's so easy. Let's see if I can pull this one up. It's so easy that you too can do it. Like for reals. Okay, and we have people that are now being activists on this level that are doing genetic engineering of weird diseases and injecting themselves as a method of protest. Because they're saying, look, this is what we can do with it, right? Okay, so there's some concern out there. There's some weird news about it. There's some discussion we're talking about in your classes, right? Did we come to any definitive discussion about it in the classes? Like, oh, it's bad, or oh, it's good, or you should be aware of it. Just keep watching the news. What did we say? The last one. Keep watching. Stand by. Okay, so now you know. So that is pretty new. Gene drive is something that is a concern with it. But we might say that we could get there with the other methods as well. We'll talk about gene drive as soon as I talk about the other methods. Okay? All right. So CRISPR is new. What have we been doing the longest? What we have been doing the longest is agrobacterium, what we call biological vectors, okay? So one of the things that we know is that when we have a petri dish with an organism in it, we can put bacteria in it, and guess what? What happens? Do they just stay apart and like go, "Ooh, you look strange"? What do? The organism and the bacteria, what happens? Yeah, and what does the bacteria do? Right? Bacteria gets into the organism by kind of eating into it, right? That's what bacteria does. Bacteria, wash it out, right? Okay, so we use bacteria, we call it agrobacterium. We use that to get the new genes into the host organism, right? So let's say we have a tomato. The flavor saver tomato. How many people heard of this one? Nobody. Okay. We got a tomato, we got a fish. And the fish has an Arctic property that we use in antifreeze. Okay? So fish has a little gene. We like the gene. We want to put it in the tomato. Why? Because we have issues with frost. We put it in the tomato, no more frost. Yay! Okay? Flavor saver because if it gets frostbit, no flavor, right? Makes sense. Okay? So now we've got our gene, our fish gene, and we've got our gene for our tomato in a petri dish. Okay? And in order to get this gene into that tomato gene in the petri dish, we attach something to it that we call agrobacterium. Okay? That means it's going to take that gene and carry it into the organism of the tomato and get it in there because it's aggressive and it eats, right? Most aggressive one is the best functioning, okay? So we use the most aggressive agrobacterium, and that is E. coli. So we use E. coli and attach that to the gene, and that is what we put into the tomato. Got it? This is the majority of the methods that we do because the other methods don't work as well. What are the other methods? Physical, we have what's called a gene gun. Let me pull that up for you. Okay, so there's your picture of a gene gun. We angle it down on top of your petri dish, right? There you go. And we pull it and it forcefully releases the gene that has pieces of gold attached to it. So it forces it into the new host organism. Make sense? Force and gold, okay? Your third method is chemical, and we quite literally electrocute it. Okay, so we put zaps of electricity into the petri dish. It makes schisms into the walls of the cells. And with the opening of those walls of the cells, then we get the gene into the product that way. Last two methods, physical gene gun, chemical methods, not very reliable, meaning either the genes kind of come out in the next subsequent generations, they don't always get in, it's not 100%, it's not even close to 70%. So we tend to use more currently everyday kind of stuff, the top one of agrobacterium. So the vast majority of what we have in our grocery stores and on the market and in the medical area, know that the vast majority of our medicines are genetically engineered, okay? So the large majority of what we consume of these come from this agrobacterium product, okay? Couple things before I get down to the goals, okay? Let me just write this a little bit differently so that we can see it better, okay? So we've got our gene that we want to put in, right? We've got our agrobacterium, okay? Now tell me, are all your genes turned on? I hope not, right? I mean, my gene for gray hair just turned on. Ah! Scary, right? super glad my gene for gray hair didn't turn on when I was 10. Right? You ever see some of those people that have like white hair and they're really young? It's like, oh, I'm sorry. Right? So our genes turn on at different times. Kind of depends on where we come from, our own genes, our family line, all those kinds of things. But they turn on or turn off or aren't on or, right? Okay. So if we're going to spend the time to put this gene in, we're wise to turn it on, yes? Okay. So we're going to put a promoter on it. Turn it on. Okay. What do we know about bacterium, like in our body? If we get bacteria in our body, what happens? What does our body do? Oh, welcomes it home and says, why don't you have a nice vacation here? I'm going to be sick for the next. No, what does our body do? Fight. So because it's going to fight it off, and anything in nature is going to fight it off like this, guess what we're going to have to put on it?
Something to weaken it?
An antibiotic, right? So it doesn't attack it. It's just like what you take when you come out of surgery, right? Otherwise, you're going to have problems. You've got to take your antibiotics, okay? So we put an antibiotic on it. We've got our agrobacterium, we've got our gene, we've got our promoter. Mostly this is what we have, okay? If there's another aspect of things, we have something that's called Bt corn, which often has a gene that we're putting into it, but also this Bt gene, and we put that on it as well. Bt, or we call it RU. We'll talk about RU in a moment, okay? All right? So is it clear that when we're doing our genetic engineering, it's what we call a cassette? Okay? Set. I'm sure I spelled that wrong. 2 S's, 1 S, I don't know. Right? The double letters just get me. Okay? So this is our cassette that we put into our new host organism, right? And once it started to develop a little bit, split the genes, come up with some kind of a tissue, right? Then we've got our product. And we can potentially reproduce it, right? With subsequent seeds, okay? Also got a new thing happening in meat. You ready? Petri. How do I spell it? With an E? Petri?
Yeah.
Okay, so this is something that started quite a while ago. Will your next burger come from a Petri dish? And they had this almost like a contest to see if they could do it. And the winning hamburger was sold for like $25,000, right? Monumental. The guy that ate it, he said, it was pretty good, right? But know that one of the things that we're doing with food is designing meat that we don't have to raise in a field. So Israel has just come up, experiment, let's see, Petri dish. Okay, so this was just like a couple of weeks ago. They're calling it clean meat, right? Developed companies around the globe, lab-grown meat. Yay, the environment. Don't have to worry about those cows in the forest. Yes.
There was something I remember my mom saying that they were doing 3D printing of meat. Like,
Yes,
plants.
yes.
I don't know if that has like.
That's another one.
Like,
They're printing dinner.
And like I don't know where it's gone. 3D printing is still like I think they're doing with art, but like it's still
I had an article that came out. Let's see. Let's find the news. See, they've got it. 3D printing evoke sensory food experiences. They're trying to even put the smells into the, yeah. Okay, so we're doing a lot of new things with foods, right? A lot. Yes.
Also the Impossible Burger.
The Impossible Burger?
Yeah.
What is this?
We pulled up a protein that makes stuff taste like meat, and they put it in vegetable.
So it's like a burger that's vegetable, but it tastes like meat?
And it
Wow.
bleeds like
And it bleeds like meat. Oh my goodness, this is amazing, right? I was at a kibbutz over the summer where they were raising a microorganism that was being put into salmon because people like it to be red. And a lot of the farm salmon isn't red. So they were putting this it's like an algae that they were growing to put it. Mind blowing what we're doing with our food, right? Okay. So let's see. In terms of our goals, we've talked about a little bit of our goals, right? Previously, we need a nice product. But one of the things that we need to make sure of is that this is going to be a kind of product that if we're going to design it in a lab and then we're going to sell it as a seed, it's got to be able to grow the same way for subsequent generations, right? I mean, we can stop the seed and give a new seed, but that kind of gets a little bit laborious, right? And some people can criticize it. So if we can develop a seed that is going to last and be the same kind of product in the subsequent generations, 5, 6 generations down the plant line or the like, that's what we want to produce. We don't want to produce something that's going to fall apart in the second generation, right? So this needs to stay stable. This needs to stay integrated and stay like this before we want to release it to the public, okay? Now, we also want to be able to do a couple of these to be successful, right? Can't just do it once, got to do a bunch of times and make sure that we've done it successfully. Eventually, we want some tissue that we can develop in the fields, grow, develop seeds, sell the seeds, distribute them around the world, right? Okay, here's a little bit of your details in terms of the biological vectors. In terms of disarming T plasmid genes, this gives you the technical jargon of what we talked about in terms of making this cassette, okay? Wanted to make sure you had all of the technical stuff, okay? There's your gene gun, right? Here's your full explanation of the chemical methods and how they're done. I'm not going to go into this because it's really, really, really technical, okay? But I want you to have it, okay? Now, precision. That's why we do this method, is for precision, okay? Eventually, we want some enzymes, and we want something that is going to produce a plant or some kind of a gene that's going to be useful in an animal, right? All right. Now, in terms of detection, some people have criticized the genetic engineering world, saying, hey, man, they don't want to label it. How many people have heard that? How many people have heard they don't want to label it? Okay. What was the argument that was given?
It was that they don't label what is GMO and what's not GMO. You can't really make an informed decision about what you put in your body.
Okay. Would you tend to look at a GMO label to find GMOs to eat?
If you're trying to avoid meat and it says burger, but it's a GMO burger, it's made of plant, actually.
Oh, okay. So that might be a good argument. That was really well done. Okay. So if you're a vegetarian, you don't want meat, right? You might look for something that can make it so that it has that flavor or that kind of similarity. Very good. Okay. Can you think of a reason why you wouldn't want to eat genetic engineered food? Maybe one or two. Okay. So if there's anybody out there that doesn't want to eat genetic engineered foods, and we labeled the products that we're making genetic engineered products, what's the likelihood that our prices are going to go up versus down? By labeling. Does labeling make it so that our prices come down? Because people aren't going to buy it. Is that what we're going to see? Okay, so that's one of the arguments they made. They said, you know, when we label this and everybody else does this other kind of label, GMO-free or no GMOs, all this kind of stuff. You've seen those labels, right? The GMO, no GMO project and all that kind of stuff. They're going to buy our products less. That means all the effort that we went into in the lab, hiring all the people, trying to perfect that thing that's so much better to produce, goes to waste because now our products, people aren't going to buy because we have this fear mongering going on. Okay. So don't want to have them labeled. Another thing about labeling, when you think about it, doing this kind of process is a pretty penny, yes? Costs a lot of money to do this in the lab. So if that's the case, right, if we're spending a lot of money to do this in the lab, that means what we're putting into it might be proprietary, right? Like, okay, it is. Meaning, if I have to put this on a label, I suddenly lose some of my proprietary knowledge. Yes? And now all of a sudden, while you're all happy to have the label there and trace things I put into it, now all of a sudden you know how I produce that valuable product that's considered proprietary or secretive, as it were, right? So there's a couple of reasons why they don't like labeling. Because of that, they went to lengths to have it registered under the FDA as what's called GRAS. So these products are called GRAS, meaning they're called generally recognized as safe, meaning the FDA has looked at these products and believes there's nothing harmful to you in eating them, okay? They're also called a substantial equivalent to food, okay? So while genetically engineered, the genetic engineered products are a substantial equivalent to the other food, which allows them to say that they're GRAS, generally recognized as safe. Okay? Now, in terms of other, I'm on the pro side, right? In terms of other aspects that are beneficial, we have pest resistance. I had a farmer on Kauai that had one kind of pest called an apple snail. Everybody dealt with it on the North Shore because somebody thought, oh, let's feed the tourists some of those nice new apple or some of those nice new snails, right? And we've got these big, huge suckers that fetch a good penny. They throw them in the taro patches and then boom, they got infested because nothing eats it. Great, right? Now, one of my farmers loses, he has about 70 to 80% loss from these snails. Is he going to survive very much longer? Probably not, right? Note that we also counted the wetland birds and found out that for every acre that is there, these taro farmers provide huge amounts of area for endangered water birds that nowhere else does. So if my taro farmer stops farming, this is a disaster for the environment, the ecosystem, the birds, everything. So it's not just this farmer suffering from snails, but if I was to engineer it, no more snails. Farmer's gonna be happy, no more waste. Don't even have to spend all that extra time digging out all the crud. Just clip off the huli, clip off the roots or pull them off, and you're off. And it's a lot faster to harvest. Do you know what it's like to harvest taro? You learn techniques of balancing your elbows on your knees because your back hurts so bad from spending about 6 to 8 hours a day bent over, okay? So lessening the amount of time to farm is wonderful, right? Oh, my back hurts just thinking about it. Okay, so disease resistance, same thing. Faster growing, oh my goodness. One of the things that happened to us in our history was we had something that was called the Green Revolution. Anybody remember it? Anybody study it? The Green Revolution. And the Green Revolution, we found that there was this really cool new kind of rice. We kind of picked out the rice varieties that were growing faster. And we had this institute in Bali called the Rice Institute. Okay, and we're developing hybridized rice, just not from genetic engineering, but hybridized that was growing faster, picked out rice that grew a lot faster. 3 to 4 months fast. That's fast rather than 6 months, right? You can feed a lot more people that way, right? So we started growing rice faster. We can do the same thing with genetic engineering, grow it even faster. Blow your mind how fast we can grow fruit, right? We can do it. Don't be a Luddite. We can increase the supply of food. We're talking about issues with population. We're talking about issues of poverty, hunger, not having enough food. We can produce this food, have it last longer on the shelves. It can be a reduced cost even, and you can get more satisfying food. Satisfying, right? Also, we've got something really amazing that they've been working on in Hawaii with the bananas. And I told you before, now we've been able to figure out a way to take vaccines, right? Common childhood vaccines that you might need, and breed them into banana plants. Meaning, when we have issues with not having enough children around the world that are vaccinated with things, which we do, think about Microsoft. Oh my gosh. Do you know how much money Bill Gates, I heard it in the UNICEF office, billions of dollars they're dedicating just to vaccines, like for reals. And it's not enough. People are dying from basic diseases all around the world in some of the poorest places, and it's getting worse. Plant trees. They'll eat a banana, and they're all covered. All we got to do is ship some trees around the world. And it's just a little root ball kind of tree for bananas, right? Could be even smaller with seed. But we can address medical issues by engineering it into the common things that we eat and having it be less expensive, right? We do talk about medicine as being for the wealthy, healthy for the wealthy, right? It's those that can afford it. Nike, just do it, right? How many people can afford their gym membership or to eat organic every day? We can design our food to be healthy for us. Cold tolerance. You know the deal. Drought tolerance, salinity tolerance. This is all what it's about. Nutrition. Bless you. We can make your food more healthy. Don't even have to get sick anymore, right? Or sneeze. Pharmaceuticals. So we are farming our best medicines right now. How many people are aware of this? No, really? So our best medicines dealing with respiratory illnesses with children, asthma, all that kind of stuff, we've had a rise in that just like threefold, right? Those are all being grown in open fields. We are also growing a lot of insulin. We are also growing a lot of medicines that are dealing with counteracting the negative effects from cancer treatments. Yay! Right? These are the best medicines grown in plants. They're not as good not grown in plants. I know that's like a double negative. That sounds weird, but they're best grown in plants. Okay? Phytoremediation, that's what we're talking about with trees, right? We talked about how we had the big oil spill, right? Gulf of Mexico. We released a bunch of microorganisms. They ate up the oil. Oil's gone. Now we don't have to worry about it, right? So we can do this, phytoremediation. Some people call this NMOD. Have you ever heard NMOD before? Environmental modification. Have you heard that before? Yes, what have you heard?
Often it has unforeseen side effects.
Ah, okay. Let's see if I can find something for you. NMOD. So here's a little piece that a lot of people attribute to NMOD. Okay, so when you hear the word NMOD, we have an agreement through the Geneva Accords not to use it. And that was specifically in relation to the military. So as you might know, that we do have some environmental modification that we've been doing. We have experimented with adjusting our weather in Alaska, California, and in Hawaii. So might not be common knowledge to everybody, but that's something that we have been doing with the emphasis on climate. But it's been discussed in the Geneva Convention quite some time ago that we weren't going to do it, but that's been changing, right? So don't confuse the two when we make that reference to NMOD, okay? So, any questions on the pro side for genetic engineering? No. No questions? Should I just wait here for a while and make sure that you don't have any questions, or is like for sure, no questions? Okay. All right. I think I'm just gonna I only have 15 minutes left, right? Do you want me to start on the anti? 5 minutes left? Oh, you're right. It's my class, my other class that comes in 15. Should I start on the other one? Give you the last 5, or do you want to take a break?
Break.
Break. Too much. Okay. All right. Enjoy your lunch. Or did you already have your lunch? Enjoy your dinner. Okay. All right. Have a good rest of your day.